Hello everyone, my name is Aditya Kumar and today I am here to give you a presentation on the topic washing machine, which is my Emertxe internship project. So here it is. The topics that I learned in my internships are introduction to C language and the C programming, and then the introduction to the embedded system, and then I learned embedded C programming, and then I learned about PIC 16F877A microcontroller and the tools, and then I studied some peripherals of that microcontroller like timer circuit and the CLCD and the digital keypad, etc. Then we will discuss about the project implementation and then project demo, and then we conclude our presentation. So here we start our introduction to C language. So why C is used? C is used for the variety of reasons, primarily due to its efficiency, flexibility, and portability. It's foundational language that has influenced by many other languages. C also excels in creating fast, lightweight applications and compilers. So where C is used in different development of the softwares like system software development, embedded software development, operating system and kernel development, firmware, middleware and driver development, and the file system development. So next we will discuss about the data representation in the C programming language. In C programming language, data is represented by the number system in decimal, in octal, in hexadecimal, and in the binary, which is 0 and 1. Literally, computer understands only two states, high and low, that we know, and these states are 0 and 1 called as binary digits. Now, byte is the smallest unit of the digital information that consists of the 8 bits. So 1 byte is equal to 8 bits. Now, we will discuss about the word amount of the data that a machine can fetch and process at one time. Example, 32-bit system have 2-bit integer and 64-bit system which have 64-bit architecture of the operating system have the size 4 bit for a single integer. Now we will discuss about the basic data types. So there are various data types in our C languages like integer, float, and character. In integer, we also have short integer and long integer. And then unsigned value. Float, we have double and the 32 bit. In integer type, we store integer values. In float type, we use to store floating type values, and character is used to store a single character in our alphanumeric type. Now there are certain control statements in the C programming language. They are conditional statements, iteration statements, and jump statements. In conditional statements, there are three categories: if else statement, nested if statements, and switch case. In iteration statements, we have while loop, do while loop, and for loop. And in jump statements, we have break and continue. Now we will discuss it one by one. Conditional statements in C. So there are conditional statements like if else, where we can single individually use if, and in the condition we write our condition. If that condition is true, the things that we write inside our if condition, if that will be executed. And in the if else condition, if the if condition is true, then the program is executed and the commands is executed. Otherwise, if the else conditions is executed, then the else will true, then the else will be if else if in if else if conditions, if condition is true, then the statements will run, and else if condition is true, then the statements in the other and otherwise all other conditions else statement will run. In the nested if conditions, there are multiple ifs. If inside if condition one is true, then we check the other condition in the other if statement, and if it is or true, then we will execute the command inside that. Then we will discuss about the switch statement. Switch and case is used where we want to use the multiple if statement, then we use a switch case where we use case 1, case 2, etc. Lastly, we will execute a default case that if other key rather than case 1, 2, 3, then the default will run. And in the we will use break so that the other case will not be executed. Now iteration statement. Now we will discuss about the iteration statements. Number one, while loop. While loop will execute continuously until the condition will get true, and its syntax will be like while condition and then statements will be true. Then we will discuss about the do while loop. The do while loop will execute at least one time, and then it check the condition. If the condition will true, then it will execute, otherwise it will stop. Now we will discuss about the for loop. The for loop in the C is a control flow statement used for repetitive execution of the block of code. It is particularly useful when the number of iterations is known or can be determined before the loop begins. The syntax for the for loop is for initialization, then condition, and then post evaluation expression. It is right as the for int I is less than or equal to 5, like, and then we will do I plus plus, and then the statements will run 5 times, 6 times actually, because int I is equal to 0, we initialize it from 0 and go up to 5. Next. Next, we will discuss about the continuous statement. Continuous statement causes a jump to the loop continuation portion, that is to the end of the loop body. Syntax do while condition statement continue. Then where the continue is executed, the other part of the code will get executed and we will be exited from that while break. Break is used to exit the loop. The statement appears after the break and the loop will be skipped. Break is similar to continue, that it goes out us from the loop, but it will also skip the statement which is right after the loop. Next, we will discuss about different operators in our C programming language, like unary operators, plus plus and minus minus, which is used to increment the value by one. Then arithmetic operators, we have addition, subtraction, multiplication, division, and the modulus, which gives momentum. Then relational operators, less than equal to, greater than equal to, and then double equal to is used to compare, and not equal to is used to compare whether the value is not equal to that value. Or then we will discuss about the logical operators, and operator, or operator, and not operator. And operator is used where we have to compare two conditions. When these two conditions are true, then both these two conditions are true, then the program will get executed. And in the or operator, in the two condition, even if the one condition is true, then the operation will be continued. And in the not operator, the condition will execute if the condition get false. Then the bitwise operator. Then we have AND bitwise operator, or bitwise operator, less than, greater than, not bitwise operator, which can be performed on a single bit. Then we have assignment operators. Equal to is used to assign a value to a variable. Plus equal to is used to increment the value and then stored in the variable which is incremented. Then minus subtract equal to is also used to minus value from a variable and then store the value in that variable. Then multiply equal to, divide equal to, and modulo equal to are also used same as the previous. Special operators, some we have size of. Size of is used to find out the size of any integer or character variable. Then we have ternary or conditional operator. The ternary operator is used to in place of the if statement. If we have two conditions, then the ternary operator will uh, choose if first condition is true or not. Then it will execute some statement one, otherwise statement two. Now we will discuss about the overflow and underflow conditions. 8-bit integral types can hold certain range of values. When we try to traverse these boundaries, overflow and underflow. Example, character have maximum value 127 and my minimum value minus 128. When we add plus 1 in the hexadecimal part of it, then we use 128 in it, then it is for the overflow condition. And similarly, when minus 129 is used instead of minus 128, we exceed its limits, then it is an underflow condition. Now we will discuss about the arrays. Arrays are the collection of elements of the same data type. We will define array in a certain way, like int integer array, and we will give size of the array in the square brackets. Like if this array have a 5 size, then in the other line we will use int array is equals to 10, 20, 45, 476. In this array we defined values in it, and then we have a character array also, in which we used to store characters. We don't have necessarily required to initialize sizing. Array can be copied in one another array by one element only using the loop. So array have index positions, index 1, index 2, index 3, index 4, index 5, and starting the index from the 0. 0, index 1, index 2, index 3, and 4. Then we have address of the each index values, and then for integer type plus 4 address value incremented, like it have 1000, then plus 4. This block 20 block have 1000 plus 4 address, and 30 block have 1000 plus 8 address, and so on. Pointers. Pointers, it is a variable used to store address of the another variable in memory space. It is a variable that is used to store address of the another variable. To have a C as a low level language being a high level language, pointers is used to returning more than one value from a function to achieve similar results as of the pass by variable. We use pass by reference technique by using the pointers. Parameters passing mechanism in functions by passing the reference. The size of the pointer in the 32-bit system is 4 bytes, and the size of the pointer in 64-bit system is 8 bytes. And the referencing pointer is used by the percent symbol and before the name of the pointer, and is used to get the memory address of the variable. Dereferencing star is used to modify the value stored at the memory address of pointer holds. Here is the example syntax for a pointer. The pointer is have 1000 value, which is the address of the this a variable, and a variable have a 10. Access the value 10, and the a variable we have to knock pointer, and then we get the value of the a variable which is stored in the a. Now we will discuss about the endians. Now we have two type of the systems based on big endians and little endians. Byte ordering of the data in a system is called as the endian. In big endian systems, most significant data gets stored in the lower memory address, and the little endian system, least significant bit gets stored in the lower memory. Here we see an example where the big endian system, least significant bit, most significant bit actually is stored in the lower memory address. And in the little endian system, least significant bit, that is the 78, is stored in the lower memory address. Now we will discuss about the functions in embedded C. A function is a block of the code that performs a specific function. Benefits of the functions that can both can be reusable, reusability, modularity, easy debugging, abstraction, and syntax. Return type we use, then we type the name of the function, then we will give some parameter to the function. Example, int add, then we will give int a and b, two variables in the function, then we will return the value a plus b. And the function will always return the addition of these two variables a plus b. Functions In functions, we can be used pass by value and pass by reference. Pass by value. This method copies the actual value of an argument into the formal parameters of the function, these parameters. And then in this case, changes made to the parameter inside the function have no effect on the actual method. Now, pass by reference method have copies the address of an argument into the formal parameter. Inside the function, address is used to access the actual argument used in the call. This means that changes made to the parameter affect the. Now we will discuss about the recursion in the C programming language. Recursion is the process of repeating items in a similar way. Recursion function example. So we have integer factorial int n. Then if n is less than equal to 1, return 1. Return n factorial n minus 1. This is the example of the factorial function, which we will do by using the technique of recursion. Now we will discuss about the strings. Strings are nothing but the arrays, character arrays, which is terminated by the null character. So example, hello. Hello string can also be write in an array like one by one character HELLO, and then we will write in the end a character \0, null character, to identify that it is a string. There are some of the operators used in the string. For length strlen we use, for comparing two strings strcmp we use, copy string into another we use strcpy, then checking strings str, then checking character strchr we use to check a character inside a string, then merging two strings we use strcat, concatenating the two strings. Now we will proceed further with the memory segments. There are different memory segments in the C programming language: text, data, BSS, heap, and stack. There are different type of memory addresses which is used in the memory segments in the C programming language. And there are also multiple storage classes like auto, register, static local, static global, and extern. Like extern is used to copy a function from one file to another. Then we can use a one function used in the one file in the another file. Static global is used to declare a file, function or file or variable globally. Static local is used to declare it locally, etc. Now we will discuss about the preprocessor and macros. A header file. A header file is a file containing C declarations and macros definitions to be shared between several source files. System में header file hashtag include stdio.h, local hashtag include my header.h, macros. An object like macro is a simple identifier which will be replaced by a code fragment defined PI 3.14 यानी कि 5 defined 5 3.14. We defined the value of the file 3.14. So wherever we use the PI, it will all automatically our system will understand that it has 3.14. We defined square x means square of a number. We define macro x cross s, x multiplied by x. So wherever we use square x, it will automatically understand that we computer that it has to make multiplication of the variable with itself. Some predefined macros are file, line, time, and function. Now, finally, we will give you an introduction to the embedded system. Definition of the embedded system: combination of the hardware and the software for a specific task. So, embedded systems are the combination of the hardware software which will be used to perform a specific task. Example: washing machine, mobile phone, industrial robot, etc. Categories of the embedded system are standalone embedded system, real-time embedded system, networking embedded system, and mobile embedded system. Mobile embedded system, as we all know, are smartphones in today's world we use. Networked embedded system are those systems which can be operated within the network. Real-time operated systems are like airbags in our car that can be used in real time. Components of the embedded system. So here are the components of the embedded system like software. Firstly, we have microcontroller or system on chip or microprocessor. Then all the components are connected to it, like memory is connected. Then FPGA, ASIC application specific integrated circuit is connected to it. Then we have ADC converter, analog to digital converter for the input of the sensors, which gives input from and then converted digital form is stored processed by the microcontroller. Then we have actuators which will perform some functions like motors and LEDs, etc. And we use DAC, digital to analog converter, to give analog value as an output. Then we have a power auxiliary system. Then we have human interfaces and human interaction. Then diagnostic port to diagnose the working of that microcontroller. Then the requirement of the embedded system is reliability. Why we require embedded system? Because it is reliable, because it is cost effective, because it uses low power consumption, it has efficient usage of power, processing power, and it uses efficiently the memory of the system. Then there are some challenges in the development trends in the embedded system. Challenges are efficient input output, operating system embedded, code optimization, and debugging. Some trends are advancement in processors we can be further implemented in future. Memory can be upgraded, operating system can be more utilized, tools can be more tools can be used, and the languages. Now the design metrics, some common design metrics we have 10% power, performance, size, NRE, billing, flexibility, safety, unit cost, time to mark, time to process. etc. Now what is a microcontroller? So microcontroller is an integrated circuit capable of performing, sorry, microcontroller is an integrated circuit capable of performing specific tasks. Design constant some of the microcontroller memory size and process capability and critical functions. This is a microprocessor basically, where all the components are separated like CPU, ROM, RAM, ports, timers. All separate components are there in a microprocessor. It is more flexible than a microcontroller and it's more design complexity it has. In microcontroller, all components are embedded in a single chip. They are all joined together, but it is less flexible and it has less design complexity. Yes, it is an advantage that it has less design complexity. There is a disadvantage that this is less flexible. Microprocessor, on the other hand, have an advantage that it is more flexible, but it has a disadvantage that it has design complexity. So here we see a microcontroller where CPU, RAM, ROM, port, timer, peripherals all are integrated in a single chip. Now, System on chip. A system on chip or SoC is a complete electronic system integrated onto a single microchip. It's a microcontroller, microprocessor, plus other peripherals. All are integrated on a single chip. It is used to design more complex embedded system, and it is used to design real-time operating system. Example, automatic gate operating system. SoC have like DC, multimedia encoder, direct memory address, CPU, DSP, NIC, audio, USB port, etc. Memory and storage. All are embedded in a single chip. Now, choosing a microcontroller, how we choose a microcontroller. So, application specific needs, we check performance requirements, we check cost and availability, tool chain and development support, special capabilities, example, the digital signal processing and communication. Now, we will discuss about the embedded C program. So, embedded programming allows direct hardware control essential for real-time applications. So we have host, target, and cross compiler. Host is a development system like MPLab IDE, where we can develop the our program for the embedded system. And for development, we use a software and ID integrated development environment called MPLab. Then we have a target system where we have to implement that code. Like in our case, we use PIC 16F877A microcontroller. And then we have cross compiler that generates code for the target architecture. The compiler is act as a translator between the code and the machine and the human and the machine. Here we use XCA compiler. Now we get started with the embedded C programming. Embedded C programming is bare metal coding, involves programming without an OS. It uses void main, void in non-OS embedded systems. Code execution starts directly from the main with no startup operating system routines. Basic understandings of the board architecture is critical. Now we will discuss about the PIC Genius board architecture. We have PIC 16F877A microcontroller, and we will test it on the PicSimLab simulator. Now we have some components like LED, buzzer, keypad, CLCD, ADC, RS232, EEPROM, etc. on that PIC board connected with it. Identify some flash interfaces like LED to start development and verify setup. Here we have the our microcontroller PIC16F877A, and some components are connected to it like digital keypad, buzzer, LED, RS232, SST, matrix keypad, CLCD, ADC, temperature sensor, EEPROM, GPIO, etc. PIC16F77A, F877A is a 40-pin device. It has 5 bidirectional ports. Port A have 6 pins, port B have 8 pins, port C have 8 pins, port D also have 8 pins, and port E have 3 pins. For every port there is a tri-state register, tris A, tris B, tris C, tris D, tris E. Data storage and microcontroller. Embedded system requires onboard memory for configuration of the lock types, EEPROM, flash memory. Data persistence is critical for non-volatile applications. Now we have some peripherals which are required in our project. LED example code and explanation, direct register address, port B output register, this B direction control, 0 output and 1 for input. Here we have a such a port for the LED blinking LED. Now we will discuss about the digital keypad. Digital keypad offers user input interface using tactile switches, interfacing considerations, switch bouncing, pull up, pull down registers, pin configuration, input mode, common uses, mobile phones, remote controls, etc. Here is our switch, which we use a metal plate and the terminal. When we press the switch, this metal plate is get contact with that point, and then the circuit is completed and the switch gets on. Here is simple configuration of the switch in our microcontroller. Switch 1 is connected to RB0, switch 2 is connected to RB1, switch 6 is connected to RB5, etc. Now we will see a code of the digital keypad. White in the digital keypad, we initialize our digital keypad, assign this B is equals to 0, C, B, X, F, 3F in hexadecimal value, 2, assign RB0 to RB5 as an input, then unset care for visual read to inside care mode, static int once is equals to 1, we declare a variable value 1 if mode is equals to level. We have two levels in the digital keypad, level detection and the edge detection. In level detection, all the value will be same, and in edge we use for to execute only one time. Then if return port B and 0x3f, and else if mode is equals to state, if switches are not released, then 1 is equal to 1, 1 is equals to 0, return port B, and 0xf. If all ports are released, then set the one's value is equals to 1. Now we will discuss about the interrupts in our microcontroller. Interrupts are the events that alter the program flow, like internal and the external interrupts, like timer overflow, switch press. Handles by our IS, our interrupt service routine, must clear interrupt flag using RETFIE to return. Here we see that interrupt is executed here. Then it will be goes to the interrupt handler, and after executing that interrupt, it will goes to the normal execution of the other task. Here is the ISR function in which we check the timer flag is equals to 1 and starting timer value from 6 and then count up to 20,000 and then LED is equals to on and off, changes the state of the LED. Then make count is equals to 0 again and timer flag is equals to 0. Clear the timer flag. So we use to 20,000 and preset value of timer is equals to 6 and set PR value is equals to 250 so that we can get a 1 second delay. Here is the formula. Count is equals to required time divided by number of ticks into Q and quantum into scaling. We have post scaling and pre scaling, different type of scaling, and have number of ticks like 256 ticks in timer. Timers and delay generation. Timers generate precise delays or measure the time intervals. Terms resolution, quantum, times per tick, scaling, post scaling. Applications, pulse generation, frequency measurement. Here is the timer 2, which has resolution 8-bit and scale, scale and post scale. Timer 2 register. Timer register overflows when it matches with the PR2. Interrupt is generated for every 250 ticks. The GIE global interrupt enable bit and enables all interrupt in the PIC 16 markets on the GIE is equals to 1 enables, GIE is equal to 0, we are disabled it. And PIE is the peripheral interrupt enable bit. We also have to enable it. Then we have a timer enabled which is 0 means timer 2 is not enabled and TMR2IE is equals to 1 means timer 2 is enabled. Now we will discuss about the CLCD, which is character LCD. Character LCD displays alphanumeric characters. Interface mode, we have 4-bit mode and 8-bit mode. Pins, we have RS pin, RW pin, EN pin, D0 to D7 data pins used for display and embedded system. It has 16 lines, which is used for displaying. And here is the configuration of these all pins and lines of the CLCD. D7 is used for reading, so our read or write operations. It is equals to 1 for read, and D7 is equals to 0 means writing. For data, we use set rs is equals to 1. For instruction, we have to set rs is equals to 0. Firstly, we will do initial configuration, then we will set re2 is equals to 1 for printing data on the CLCD, then we set port D is equals to data to give data from the port D, then we say use signal or enable re is equals to 1, then we will give some delay, then after delay, we have processing time like delay method and polling method. In our case, we use delay method because polling method cannot be used because pin is already grounded and RS value, sorry, D7 value, RW value is already zero in 0 in our case. So reading operation cannot be performed. So here function of a to write on CLCD write unsigned care data and we give unsigned care mode. CLCD RS is equal to mode CLCD data. Like you check, we give delay of a predefined, we use a predefined delay function and give a 100 microsecond delay. Then after we give 4.1 millisecond delay as per the data sheet. Now we will discuss about the buzzer and the fan. So buzzer is connected with the RC1 and RC2 port. If tris C1 is equal to 0, tris C is equal to 0, and to turn on the buzzer, RC1 is equal to 1, and to turn on buzzer, RC1 is equal to 0. We have to set to turn on fan, we have to set RC2 is equal to 1, and to turn off fan, we have to RC set is equal to 0. Here is a buzzer, here is a DC fan, and port C is a 8-bit port, which have 8 port line RC0 to RC7. Now we will discuss about the project implementation finally. So, so purpose of this project is to simulate a washing machine to replicate real world functionality. Tools that we required are PicSimLab, MPLab, IDE, and XCA compiler. Our main focus is on the component cycles and operational parameters. Project scope insights into washing machine operations, control system design, simulation techniques, application of algorithms in intelligent applications. Assumptions are all peripheral simulated and no real hardware interfacing is done. Now, functional requirement overview. We have a microcontroller. So to power on our microcontroller and our washing machine, we use switch 5. Then to pause and stop our operation in the washing program and the running screen, we use switch 6. For navigation, we use switch 4 And for single press, it will scroll between the functions. And for long press, the switch 4 is used to select a program or a function. Door status, if switch 1 is pressed, then we will consider that the door is open and shows a warning that the door is open, please close the door. Then we have the display washing status on the CLCD buzzer, and instead of motor, we used fan here. Now, power on screen. Input, we have switch 5. If we press switch 5, then the power on screen is on, and then it will show a powering on washing machine message. Now next, we have washing program screen having the 12 washing programs: daily, heavy, delicates, wet sheets, expert store, wash only, spin only, rinse plus dry, etc. And we use the switch 4 to scroll between them. To select a particular program, we have to long press the switch 4. Then the water level screen, we have auto, low, medium, high, max, and we also switch 4 have the same functionality for scrolling and the selecting. Then we have the start screen. Switch 5 is used to start and switch 6 is used to stop the program. Next, we have a function screen in which timer is running and all functions are showing like wash, rinse, and spin. And 6 button is used, switch is used to pause that function of the washing machine fan and is stopped. And 5 is used to resume and the program, and the fan will start. After completion for indoor status, if we press switch 1, then the it will shows a warning, and then after the completion of the time, it will show the program completed, remove floats, buzzer will ring, and then after we will go back to the function washing programs. Here we open our MP lab for the project implementation and build our project. Build is successful. Then I go to the PicSimLab board and then load the hex file. Hex file is loaded. Now we use switch 5 to turn on our washing program, and washing machine is powering on. Now I use switch 4 to scroll between the options. Let's consider I choose woolens. Then I have to long press the switch 4 to select it. Now it will ask me about the water level. So let's consider we take high water level, and I press switch 4 to select it. Then switch 5 to start it, and the function wash is showing, timer is running, fan is also running. Now to pause it, I press switch 6, and then after pressing switch 5, it get resumed. So what if door is open, switch 1 is pressed, buzzer is running, and it gives a warning to us that door is open, please close the door. Now rinse is function is showing and timer is still running. After a certain time, it's rinsing the cloths, and then spin is showing. So after program completion, a 3-second buzzer will ring and it shows program is completed, and it will return to the washing program screen. Thank you so much. With that, I concluded my presentation and the project. With this, that in this internship, I learned about C programming, embedded C, PIC 16F877, a microcontroller, and implemented all knowledge in the project washing machine simulation using PicSimLab. Served as an effective tool for learning and applying concepts in embedded system. It offers a hand-on experience that complemented theoretical knowledge and provided a foundation for further exploration in the field of automation and control system. With this, I thank you, Emertxe, for providing me this opportunity and giving me such a knowledge about the embedded systems. And thank you so much.